Welcome to this explainer. Look, if you're an emergency medical services provider, a government health official, or a private hospital administrator, you already know that buying an ambulance is so much more than just comparing price quotes. It's really about finding that perfect, critical synergy between automotive engineering and life-saving healthcare. So today, we're exploring exactly how to navigate this international market and source top-tier emergency vehicles effectively. First things first, we've got to completely shatter some outdated perceptions of this market. If you're thinking we're just talking about a low-cost assembly hub, well, think again. It is incredible to see how this space has rapidly evolved into a highly sophisticated manufacturing ecosystem. We are now talking about factories fully capable of producing high-end mobile intensive care units, complete with negative pressure technology and rugged off-road capabilities, and all of it is built directly onto world-class chassis from brands like Mercedes-Benz, Ford, and Iveco. Here is our roadmap for today. We'll be covering 1. The modern Chinese ambulance. 2. Inside the medical cabin. 3. Choosing the right chassis. 4. The manufacturing workflow. And 5. Smart procurement and logistics. All right, let's jump right into Section 1, the modern Chinese ambulance. To really understand this market, we first have to look at the baseline standards of today's emergency vehicles. As you know, in the global market, an ambulance is absolutely never a one-size-fits-all product. Manufacturers build to strict global standards, and depending on your region, they're adapting to either the European EN 1789 standard or the US KKK specs. You're typically going to see 3 primary tiers. Type A is for basic patient transport, non-emergencies, basically. Type B steps it up for basic emergency treatment. But Type C, the Mobile Intensive Care Unit, or MICU, that is where the real engineering challenge lies. It has to be designed for intensive care and continuous monitoring while hurtling down a highway at high speeds. You know the difference between a basic build and a truly top-tier one? It's immediately obvious the second you look at the cabin construction. Notice how professional manufacturers have moved way past those traditional wooden interiors where equipment is simply bolted to the walls. In a high-stakes environment, that just doesn't cut it anymore. Instead, they integrate medical-grade ABS or aluminum alloy composite panels using vacuum forming. These materials are antibacterial, flame retardant, and incredibly easy to disinfect. It's a huge indicator that you're dealing with a world-class builder. Moving on to Section 2, inside the medical cabin. Let's peel back the layers and look at the space where the real life-saving actually happens. So, when you're evaluating a manufacturer, you really have to ask yourself, what actually separates a basic van from a true mobile hospital? Because, let's face it, we are living in a post-pandemic world, and the requirements for emergency medical response have fundamentally changed. The engineering simply has to reflect that 24/7 high-stakes demand. For infectious disease control, the absolute gold standard right now relies on negative pressure. A high-quality ambulance has to maintain a pressure difference of -20 to -30 pascals compared to the outside atmosphere. It uses a dedicated ventilation system which is completely separate from the driver's cabin, with a filtration efficiency of 99.97% for particles as tiny as 0.3 micrometers. That is absolutely crucial to protect both the public and your frontline workers from dangerous airborne pathogens. On top of that, you've got to ensure your life-saving equipment, things like ventilators, defibrillators, and infusion pumps, receive clean, uninterrupted power. I mean, imagine a ventilator losing power halfway to the hospital. No way. The stakes are literally life and death. Because these are high-draw devices, installing pure sine wave inverters is mandatory to protect sensitive electronics. Couple that with a dual battery system, and you ensure the vehicle's engine can always start, even if the medical lights and equipment have been running heavily while stationary at a chaotic scene. If you look at the comparison here, it's pretty wild to see the massive jump in technical requirements when upgrading from basic transport to an advanced MICU. Look at the power supply. It jumps from a standard 1,000-watt inverter up to a heavy-duty 2,000 or 3,000-watt pure sine wave unit. And check out the oxygen systems, moving from 2 basic 7-liter cylinders to heavy-duty 10 or 15-liter cylinders, all integrated with a central manifold and automatic changeover valves. It's just an entirely different level of engineering designed specifically to keep patients stabilized in the most critical moments. Okay, on to Section 3, choosing the right chassis. Because all of that advanced cabin technology we just talked about, it needs a really solid foundation. A major advantage of sourcing from specialized manufacturers here is their access to a wildly diverse global supply chain. It's actually fascinating how local geography dictates your choice.
For instance, you might choose the Ford Transit for its universal parts network and easy local maintenance. Or maybe you opt for the Mercedes-Benz Sprinter for that high-end ICU comfort and brand prestige. Then there's the Iveco Daily, which is fantastic for heavier, modular box-type ambulances because of its robust ladder frame. And hey, if you need legendary mechanical reliability in remote areas of Southeast Asia or Africa, you're more than likely looking at the Toyota Hiace. But what if your EMS teams operate in extreme terrain? Places where a standard rear-wheel drive vehicle is just going to fail. When simply getting to the patient is half the battle, specialized four-wheel drive configurations are an absolute must. Manufacturers offer solutions using specialized off-road chassis or platforms like the Maxis, which are specifically engineered to navigate unpaved rural roads, washed-out trails, or highly mountainous regions without compromising the medical environment inside the cabin. Let's shift gears to Section 4, the manufacturing workflow. Once you've got the chassis and your specs nailed down, how does it all actually come together on the factory floor? Well, this 5-step workflow is exactly where automotive engineering truly meets healthcare. It really proves just how complex a proper conversion is. First, the shell is heavily reinforced and insulated. Second comes the electrical harnessing, and they use independent automotive-grade wiring looms to prevent dangerous shorts. Third is the interior fitting with precision-cut cabinets. Fourth, they integrate the stretchers and medical devices. And finally, step 5 is rigorous final testing. This includes water leakage checks, electrical load testing, and road simulation to ensure absolutely nothing rattles or shakes loose during a high-speed response. And speaking of that rigorous testing, European Standard EN 1789 compliance is incredibly critical here. Leading manufacturers build to these exact requirements, which includes 10G crash testing for all interior fixtures. To put that into perspective for you, 10Gs is the kind of force a fighter pilot experiences. Details like rounded radius corners on those precision-cut cabinets aren't just there for aesthetics. They literally prevent severe injuries to paramedics during a sudden stop. It's all about ensuring the caregivers are kept just as safe as their patients. All right, bringing it home with Section 5, smart procurement and logistics. Because engineering a world-class ambulance is really only half the battle. Now, we actually have to execute the purchase and get the vehicles safely delivered. So the most crucial distinction you have to make in this market is understanding who you are actually buying from. You really need to contrast a middleman trading house with an actual physical factory. Partnering directly with a physical factory that has an in-house engineering team guarantees you long-term technical support. Think about it. If an oxygen system circuit board fails 3 years down the line, a real factory can pull the exact wiring diagram for your specific build and send the replacement part. A trading house? They might not even exist by then. When we dive into the logistics side of things, here's a really great insider strategy for you. Always ask for OEM preparation packages. This means the factory pre-wires and creates mounting brackets for your specific preferred medical brands, like Mindray or Zoll, so your local teams can essentially just plug and play later. To maximize your shipping economy, aim for a minimum order quantity, or MOQ, of 2 to 4 units so they fit perfectly into a 40-foot container. And definitely plan your fleet upgrades early. Standard conversions take about 15 to 30 days, but complex negative pressure units, those can easily stretch past 45 days. Protecting these highly advanced medical environments from ocean elements during transport, it's honestly just as critical as the manufacturing process itself. Smaller, van-based ambulances tuck safely inside 40-foot high cube containers to prevent any corrosive ocean salt spray damage. But those larger, heavier box-type ambulances physically won't fit, meaning they require specialized roll-on/roll-off vessels or flat rack containers to make that journey safely across the ocean. 10 to 15 years. That right there is the designed lifespan of a high-quality professional ambulance conversion from these facilities. Provided, of course, that the vehicle and the medical cabin are properly maintained according to factory protocols. When you invest in composite materials, pure sine wave inverters, and professional automotive-grade electrical looms, you're literally buying a decade and a half of relentless reliability for your emergency responders. So as you evaluate your next fleet upgrade and, review those budgets, I want to leave you with a final thought to mull over. Pause and ask yourself, is your current procurement strategy truly balancing the budget with the rigorous medical standards and uncompromising safety your EMS teams deserve out on the front lines? Thanks so much for joining me for this explainer. I really hope this deeper dive into the procurement process empowers you to make the absolute best, most informed decisions possible for your medical fleet.